ClawGym is one of the more interesting agent papers to drop this week because it is not another chat benchmark. It is aimed at Claw-style personal agents, systems that work inside local folders, call tools, update files, and have to leave a workspace in the right final state. For builders, that is much closer to the kind of software factory harness we care about. The core idea is simple. If an agent only needs to answer a question, we can grade the final text. But if the agent has to inspect JSON files, run a script, fix a failure, generate reports, and keep state for a rerun, the benchmark needs a workspace and a verifier. ClawGym focuses on that stateful loop: discovery, tool use, file edits, feedback, and verification. The source-reported numbers are useful. ClawGym data contains 13,500 filtered, executable tasks. The authors then collect 24,500 interaction trajectories from teacher rollouts and build ClawGym-Bench as a 200-instance diagnostic benchmark. The important caveat is that the GitHub page says code, datasets, benchmark assets, and model checkpoints are still under internal review and will be released soon. What I like is the dual data synthesis pattern. One route starts from personas, scenarios, and atomic operations, so tasks look like realistic user requests. The other route starts from OpenClaw skills, so the tasks stay grounded in real operations. That combination matters for a software factory agent. User intent alone can become vague, while tool lists alone can become artificial. You need both. ClawGym-Bench is also shaped more like a real agent workload than a toy coding set. The paper lists 6 categories: productivity and collaboration, systems and automation, analysis and reasoning, content and domain support, planning and knowledge, and software development. That mix is important because a real coding agent has to do more than write code. It has to communicate, inspect state, organize context, and automate operations. The reported results are directional, not independently verified yet. Claude 4.7 Opus has the highest ClawGym-Bench average in the table at 77.81. The tuned ClawGym agents do improve their Qwen backbones, with ClawGym 30A 3B reaching 56.82, above the much larger Qwen 3235B A23B baseline in the paper. So the takeaway is not that small models beat the frontier. It is that agent-specific trajectories appear to buy real capability. For our channel, the most useful lesson is the harness pattern. If you want a coding agent that can actually ship work, you need isolated task sandboxes, realistic workspace fixtures, automated verifiers, trajectory logging, reward filters, and independent review. ClawGym gives us a research-shaped version of that loop. It maps directly onto the kind of repo task system we would want around Hermes, MyDash, and PyCoding agent. My recommendation is to cover ClawGym now as an early research blueprint. It is directly relevant to coding agents, personal agents, and the software factory stack. But I would be careful with the wording. The paper reports strong evidence, while the public resources are still marked coming soon. If you want more grounded AI model and coding agent breakdowns like this, subscribe to Fluid Coding and AI.